Have scientists found an anti-cancer vaccine? Researchers from Stanford University used stem cells to create a vaccine that has proven effective against breast, lung, and skin cancer in mice. To produce the vaccine, the scientists turned to induced pluripotent stem cells, IPSCs, or stem cells that are generated from adult cells. Over a decade ago, Japanese-based scientists showed for the first time that adult cells can be genetically reprogrammed to behave in the same way as pluripotent stem cells. These cells can take any shape or function, specializing into whatever type of cell the body needs. Embryonic stem cells are probably the most well-known type of pluripotent stem cell. As Wu and colleagues write, about a century ago, scientists found that immunizing animals with embryonic tissue caused them to reject tumors. Over time, this led scientists to believe that embryonic stem cells could be used as a sort of vaccine against cancer tumors. The main challenge of anti-cancer vaccines, however, is the limited number of antigens, or foreign agents that elicit an immune response, that the immune system can be exposed to at once. But, as Wu and his colleagues write, using IPSCs generated from the patient's own genetic material has, in theory, a range of immunogenic advantages. They present immune T cells with a more accurate and representative panel of a patient's tumor immunogens. So, the researchers, led by Joseph C. Wu, of the Institute for Stem Cell Biology and Regenerative Medicine at Stanford University in California, set out to test this hypothesis in mice, and they published their results in the journal Cell Stem Cell. Immune system primed to reject tumors. Wu and colleagues used the mice's own cells to create the IPSCs, which they later vaccinated the rodents with. The vaccine targeted several tumor antigens at the same time. As the researchers explain, the main advantage of using whole IPSCs is that the vaccine no longer has to identify the perfect antigen to target in a specific kind of cancer. We present the immune system with a larger number of tumor antigens found in IPSCs, explains Wu, which makes our approach less susceptible to immune evasion by cancer cells. In fact, the researchers discovered that many of the antigens found on the IPSCs could also be found in cancer cells. So, when the rodents received the IPSCs shot, their immune system reacted to the IPSCs antigens. But, because the antigens in the IPSCs were so similar to the ones in the cancer cells, the rodents also became immune to cancer. The vaccine almost primed the rodents' immune systems to eradicate tumor cells, Wu explains. Of the 75 treated mice, 70% completely rejected breast cancer cells, and 30% had smaller tumors within 4 weeks of getting the vaccine. And, the same thing happened in lung and skin cancer models. What surprised us most was the effectiveness of the IPSC vaccine in reactivating the immune system to target cancer. This approach may have clinical potential to prevent tumor recurrence or target distant metastases. In the future, a person who has been diagnosed with cancer might be able to use their own blood or skin cells to form IPSCs, which could prevent tumor recurrence. Likewise, healthy individuals may soon be able to use their own cells to prevent cancer altogether.